Dhruv. Good evening, everyone. I am Vansh Gandharva, and today our team is going to tell about processor features of Snapdragon 8 Elite Gen 5. So let us begin with the first slide. So as we can see, that Qualcomm has released its Snapdragon 8 Elite Gen 5 processor recently. For the starters, the chip has already been rebranded once. Its original name was the Snapdragon 8 Elite 2, so that it followed in the footsteps of Snapdragon 8 Elite that went into flagship phones like the Samsung Galaxy S25 Ultra. However, just like the Microsoft when it skipped the Windows 9 and Apple when it went from iOS 18 to iOS 26, Qualcomm decided to skip a few numbers and go straight to the Snapdragon 8 Elite Gen 5. This coincides with the fact that it's actually the fifth generation chip, as the name suggests, Snapdragon 8 Elite Gen 5. So today I'll be presenting the Elite Gen processor uh, with its overview. So let us begin. As we all know that this processor is one of the most powerful processors out there, and we can also see its key features like it has the agentic AI integration, which basically shifts the basic generative AI to agentic AI on a device intelligence capable of understanding user intent. And it can also learn via some personal knowledge graph as well. Also, it is provided with a professional media toolkit, which introduces world's first mobile support for the advanced professional video APV codec, and as well as there is a ISP, which is 20-bit as well. Now we can also see that the next gen connectivity features. So basically, it features the Snapdragon X85 modem and Fast Connect 7900, enabling faster 5G Wi-Fi and precise location tracking as well. Finally, coming to the fabrication part, earlier the Snapdragon 8 version was 4 mm, it was basically fabricated by Samsung, but now the Snapdragon 8 Elite Gen 5 is fabricated by the TSMC, which is basically a 3 nm fabrication, which was earlier 4 nm. And it also achieves a overall 16% SoC power saving as well as nearly 2 hours of additional battery life. Now moving on to the next slide. So as we can see the model comparison between the Snapdragon 8 Elite Gen 5 versus the earlier Snapdragon models, which is basically a Snapdragon 8 Gen 5, which is non-elite, and the Snapdragon Gen 1. So we can see the CPU architecture. Both Snapdragon 8 Elite Gen 5 as well as the Snapdragon 8 Gen 5 have the third generation custom Oryon CPU, while the Snapdragon 8 Gen 1 has ARM. There are difference between their core configurations. As we can see in the Snapdragon 8 Elite Gen 5, it's 2 prime plus 6 performance as well as the Snapdragon 8 version, while the Snapdragon 8 Gen 1 has 1 prime plus 3 gold plus 4 silver core configuration. And we can also see the peak clock speed in the table. The Snapdragon 8 Elite Gen 5 beats its previous models, which is up to 4.74 gigahertz compared to the Snapdragon 8's 3.8 gigahertz, while Gen 1 3 gigahertz. Also, as I said, that the previous version was manufactured by Samsung, which is 4 nm, while the now new versions are being manufactured by TSMC, the 3 nm version. Yeah. So moving on to the next slide. So as we can see the AI enhanced global connectivity. So in the modern era of artificial intelligence, the connectivity features are also improved by the Qualcomm, which includes the Snapdragon 8 Elite Gen 5 integrates AI into its connectivity as well, which is a major advancement. The Snapdragon X85 5G modem can reach up to speeds of 12.5 5 gigabytes per second, and it uses AI to maintain strong signals even in crowded or low network areas, which is a strong improvement. Then we have Fast Connect 7900, which I also talked earlier, which combines Wi-Fi 7 as well as Bluetooth 6.0 and the ultra wideband. UVV is basically useful for precise location tracking, such as digital car keys and indoor navigation. Another important feature is power efficient Bluetooth, which reduces the energy consumption by 40% during wireless usage. So, overall, the connectivity is not just faster, it is also smarter and more efficient. So, moving on to the next slide. Yeah, the gaming features. So, gaming features are one of the most important features that generally students see. So let us move to the gaming performance. This processor is designed to deliver console level gaming on mobile devices. It supports real-time ray tracing, which improves lighting, reflections, and shadow for more realistic graphics, as well as it is combined with some Unreal Engine 5 technologies like Lumen for lighting, as well as Nanite for detailed geometry. Now we can also see the another key feature is Arduino high performance memory, which is an 18 MB on chip cache. This improves frame rates, which is very important in the games. While the chip also supports 120 hertz as well as 144 hertz displays, ensuring smooth gameplay as well as the Snapdragon Game Super Resolution uses AI again to upscale graphics, giving high quality visuals. Now, moving on to the next slide. So, we will now see the hardware overview of the processor. So, as we can see, there are execution pipelines. So, it employs four dedicated load store execution pipes for high speed memory operations, as well as it helps in memory queuing. So basically, it manages a really deep load queue which has 192 entries and a store queue which has 56 entries to handle the memory ordering hazards. So basically, like a general load store architecture, it has 192 entries for the load and 56 entry for the store. And we can see that data cache features a 96 kilobyte six-way associative L1 data cache. So it is six-way associative, not fully associative. And it is also optimized for concurrent read-write operations. And we can also see the high speed memory support, which is supported by LPDDR5X memory with clock speed up to 5300 megahertz and density is up to 24 gigabytes. So basically, it is really good. And we have a strong throughput here, which is integrated support for UFS 4.1. And using this, we can use really ultra fast data transfer and app loading, as well as we can also see the designs are also improved by about 20% while still reducing power usage by 35%. And the efficiency is really going higher and higher, as well as we are using Orion CPU, which will now be in detail explained by Swastik. Thank you.
Hello, my name is Swastik Pramanik, a third year EC student, and I'll be continuing this session from where once left off. So now we will be entering into the core architecture of the processor, mainly the CPU part. And as it's shown in this slide, one of the biggest architectural changes is the shift to an all big core design in the processor. Traditionally, processors used to be a mix of big and small cores, but this chip removes efficiency cores entirely. Instead, it uses two prime cores, which are up, work up to 4.61 gigahertz, and six performance cores up to 3.6 gigahertz. The design improves performance by about 20% while reducing power usage by 35% under heavy workloads. The efficiency is achieved through the advanced design of Orion cores rather than relying on smaller cores. Now we'll go into the fetch and decode part of the process. CPU, Orion CPU. It has fetch and decode stage. The processor can fetch up to 16 instructions per cycle, which is extremely fast. It uses a branch prediction, reducing delays when CPU guesses the next instruction. And then we have instruction decoding. The instruction bundles are processed by decoders and are capable of to decode up to 8 micro operations per cycle. This ensures smooth, efficient instruction pipeline, minimizing delays and improving performance. And this also optimizes the branch for exactly up to 13 cycles. Now we'll go into the rename and retire unit, REU. In here, processor uses register naming to eliminate false dependencies between instructions. It contains over 400 physical registers in each of the integer and vector pools to prevent stalling during deep out-of-order execution. This also supports out-of-order scheduling, reservation station track in-flight producers UOPs and issue them immediately when source registers are ready. It also has a reorder buffer ROB size to track more than 650 in-flight UOPs from rename through to completion and retirement. This allows CPUs to execute instructions out of order, meaning it doesn't have to wait unnecessarily, improving speed and efficiency. Next, we'll go into execution units. The processor has two execution units, integer execution units and vector execution units. The integer execution units include 6 ALU execution pipes handling up to 64-bit wide integer data types simultaneously. And the vector execution unit contains four 128-bit wide vector pipes supporting SIMD and floating point instructions like FP 16, 32, and 64. It also has result forwarding, which employs a wide result forwarding network, pushing data from in-flight producers to directly to consumer from minimum issue to issue. See, this processor also supports 14.16, 32, and 64, and for integers, int 8, 16, 32, etc. Now, moving on to load and store unit. It includes four dedicated load store execution pipes. It also has out-of-order memory managing 192 entry load queue and 56 entry store queue. It also does hazard checking. Hardware continually checks memory ordering hazards. If a load needs data from an older source still in queue, it uses direct store to load forwarding, thus increasing efficiency. The L1 data cache features finely banked 96 KB 6-way associative L1 data cache optimized for concurrent read and write operations. Now we will look into the graphics and agentic AI systems. It contains Adreno 840 GPU, includes a tile memory heap, which improves bandwidth usage to increase efficiency about 20%. It fully supports advanced gaming technologies like Nanite and Lumen. On the AI side, the Hexagon NPU is designed for agentic AI, meaning it can understand users' intent, perform multi-step tasks, and work across applications. Additionally, the CPU now includes hardware matrix acceleration hardware, which directly supports AI computation. And it is also closely related to neural networks such as transformers. Now, I'll pass this over to Aditya Jain, one of my teammates.